Today we're going to look at how we can use matrices to create and identify transformations. So the first ones that we're going to look at are translations. So translations are ups and downs. And with our image that we have here, I'm going to label these vertices. I'm going to say that this one right here is vertice A, this one right here is vertice B, and this one's vertice C. Now I can put these vertices in a matrix if I say this is point A. Let's try that again. And this is its X value and its Y value. And this is vertex B and vertex C. Now, if I want to make it translate left 3 units, I can do that just from the graph. I can move all of my points 3 units to the left. So if I move A 3 units left, that's going to go here. And I'm going to label it A prime just because it's what A has been shifted into. And I can do the same thing with B and C. I can draw it in, which we know how to do these transformations from previous lessons. But with a matrix, we've got to remember that any kind of translation, it either uses addition or subtraction. And it's easier to use addition so that we don't have to worry about distributing that negative through everything. So we're just going to look at subtraction as adding negatives. Now, when we add matrices, we know that they have to be of the same dimension. So if this original image created a 2 by 3 matrix, I have to add another 2 by 3 matrix. Remember, the first row are the X's, the second row are the Y's. Well, what happens during this translating left 3? Well, all of the X's lost a value of 3. And so for every X, it lost 3 units, but then the Y's didn't move at all. So these Y's would be zeros. And now when we add, right, we'd have this plus this would give us the first number in our matrix. We have this plus this is our second number, and so on and so forth. So if I do the addition, I would end up with, I'll go across the top first. 1 minus 3 is negative 2. 2 minus 3 is negative 1. 4 minus 3 is 1. And then go across the bottom. Nothing's going to change because all of them are adding 0. So it's just 1, negative 2, and 3. These should be the coordinates of my new vertices. And if I double check the graph, these do work out. They do match what I have, except for, now that I'm checking it, this isn't a 3. I wrote it down wrong to start with. That should be a negative 2. So double checking your picture is helpful. Okay, now let's translate up 5. So again, if I took my original and moved everything up 5, I can do it just from the image. And I'm just giving them the same names. You can call them double prime or triple prime by putting another little mark up there, but I'm not going to do that here. Okay, so if I take my original matrix and I'm translate it up 5 units. Remember, the first row is X's, the second row is Y's. So how do the X's change if I translate up? Well, they don't. So all 3 of the X values stay the same. Then all 3 of the Y values increase by 5 units. So we're going to add 5 to each of those here. So then that would give me nothing changing in the X's, all of these going up by 5. And there would be the values of the blue triangle that I translated up 5. Now for this next one, let's try to do the matrix first and then we'll graph it and check it. So if I take my original matrix and I want to make it move right 4 and down 3. Well, right 4 would affect the x's and they would all increase by 4. Then down 3, well, that means all the y's would lose 3. So algebraically, if I add these matrices together, I get 5, 6, 8, -2, -5, -5, right? And that would be the coordinates of my new vertices. Now let's check it out with our graph. So A prime is supposed to be 5, -2. If I take A and I shift it right 4 and down 3, it's right here, which is indeed 5, -2. Do the same thing with B, right 4, down 3. That is right here. So that's 6, -5. Yep. Oh, my other point disappeared. And C, move it 4 units right, down 2, 3, sorry. That would be here. And so then there is my last triangle. So anytime you have translation, you're going to show me with matrices that you are adding either to the x values or y values or adding negatives to make it move left or down. Now for dilation, dilation is like a shrinking or expanding. For these, this is multiplication. And for dilation, you're going to use scalar multiplication. So if I want to dilate this by 3, so that'll be expanding it because that 3 is larger than 1, I'm just going to take my original matrix and I'm going to multiply it by a 3. So remember, this is still A, B, C. And so these are going to turn into 3, 6, 12, 3, -6, -6. Now it does look like I'm going to go off my graph a little bit, but that's okay. If I were to draw this to kind of give it an image, I have 3, 3, 6, -6. And then 12, -6, I mean, this grid only goes to 8, so I'm going to say that it's out here and maybe make a note to myself that that's 12, -6. And so this is what dilating by 3 would turn into. Well, what if I dilate by a half? So this is shrinking. Well, you're going to multiply using a scalar of 1/2. These are all very nice numbers. Just remember that we don't use decimals in a matrix, so we do want to keep their fraction form. And then we're going to graph it. 1, -1, and 2, -1. So it's this itty bitty triangle right there. That's what a dilation by a half would look like. All right, we've translated, we've dilated. Now let's talk about reflection. And I've kind of got some empty boxes in here because we're going to actually create the 2 by 2 matrix that we're multiplying by. We're going to think through it, okay? So if I am going to reflect over the x-axis, I know that that means my y's are going to change. So 1, 1 would become 1, -1. And 2, -2 would become 2, 2. And 4, -2 would become 4, 2. And so this is what it would look like reflected over the x-axis. So what is it that I have to multiply by to get that result? And so remember that when you multiply matrices, to find this number here, I have to take the first row times the first column. And then to get this number here, I have to take first row, but times the second column. So think about what has to happen in order for those to become the values that we have over in this matrix that we know is the result that we want. Well, this first upper left box would have to be a 1 because 1 times 1 is 1. But then I need this 1 to turn into 0, so I would need to multiply it by 0. If I wanted to show my work, this would be 1 times 1 plus 0 times 1. The result of that is 1. And I can check that the whole way through. If I do row times second column, 1 times 2 is 2, plus 0 times negative 2, that is still 2. And it works for the third column as well. So now we need to figure out the bottom row of our multiplier, the 2 by 2 that we need to multiply by for this reflection to happen. So I need this times this to give me negative 1. And this bottom row times this column to give me positive 2. And this row times this column to give me 2. Well, I noticed that the numbers match the bottom row, which means whatever's in that top row of that 2 by 3 isn't going to matter. So this has got to be a 0 because I'm going to multiply those by 0. But then the bottom row does change signs, so I'm going to have to multiply by a negative 1 in order to get the result that I want. So I know that there's lots of highlighting going on here. I'm going to try to get rid of some of it. But kind of a big takeaway here is that if you're going to reflect over the x-axis, that is the 2 by 2 matrix that you need to multiply by. Okay, we're going to do the same thing with a different reflection. We're going to reflect over the y-axis. And we're going to configure it the same way. I'm going to look at, well, what would the result have been? And I'm going to figure out what we would have needed to multiply by. So take your original image and we're going to reflect it over the y-axis. And I would get this guy here. Do you remember that you want to keep an order? Okay, so the 0.11 has now become negative 1, The 0.2, negative 2 has now become negative 2, negative 2. And the 0.4, negative 2 has become negative 4, negative 2. We're going to think through this the same way, right? What has to go in that 2 by 2 matrix for this result? Well, I notice that this top row is the same as this top row, but everything's changed signs. So I'm going to have to multiply everything up there by a negative 1, but then add nothing else to it. And for the second row, when I'm looking here and here, nothing has changed. So I need it to stay the same. So I need to clear out that first term in the column and then multiply that bottom row just by 1 in order for it to stay the same. So this would be reflecting over the y-axis. And notice how they are very similar, right? It's pretty much the identity matrix, but where the 1 and negative 1 is. Okay, for this next one, we're going to reflect over the line y equals x. And so y equals x is that line that goes through 1, 1, 2, 2, 3, 3, 4, 4, and so on. It's a diagonal. And this one might look more complicated, But this right here is a big hint. I'm going to swap X and Y values. So again, we're gonna figure out what this would have to be here, but I know the result would be swapping my X's and Y's from the original. So as I look at this, like, okay, well, in order to find that first row, first column, I need it to be a 1, which looks like that one, but we've got to remember that it's actually this one. So that's going to happen all the way across the board, right? Second row, first term is this one. Third row, I'm sorry, first row, third column is this one here. So what I need to do is I actually need to clear out that first column number, and then I just need to use the second column number, or the second row of that column, to get to here. Okay, well then what would the bottom row look like? Well, the bottom row is going to be almost the same thing, but the bottom row became the top row. So I need to use that top row, but ignore the bottom. So again, almost like the identity matrix, except for where the ones are. And that's what reflecting over the line y equals x looks like. And if I were to plot it, 1, 1 doesn't move. And then I get -2, 2, and -2, 4. And so just to give you a visual, that's what that image would look like reflected over the line, y equals x. So for those, you really do have to think about what goes where and why. You can try to memorize those 2x2s. But if you think about what the graph does and what the result is, you can recreate them on your own. The last one that we're going to do is rotations. And we're going to rotate 90 degrees, 180 degrees, and 270 degrees. So for these visually, so for 90 degrees, this is what I do. I'm gonna stick with point A up here. And I go from the origin and I go right 1, up 1. So if I rotate that 90 degrees, it would now be down 1, right 1. And I'm going to do the same thing for all of the points. So instead of down 2, right 2, if I rotate that 90 degrees, it would now be left 2, down 2. So that's right here. Oops. Try that again. Eraser. Nope. Eraser. Here we go. All right, now I'm going to get rid of some of this. There we go. Okay, I think I'm back now. All right, if I take this kind of arm mechanism and I rotate it 90 degrees, it was down to right 2. Now it's going to be left 2, down 2. So that's going to go right here. And then on my last one as well, I'm not going to draw the arm here, but it was down to left. I'm sorry, down to right 4. Now it's going to be left 2, down 4. So this is what my new one would look like if I rotated that 90 degrees. So its new coordinates are 1, -1, -2, -2, and -2, -4. So just like last time, we're going to look at what would this have to be here, that when I multiply that this is the result. Well, it looks like the top row became the bottom row. So that means we want to clear out the top of the column and only use the bottom column, or bottom row, bottom of the column, which is the bottom row. And our last row of that 2 by 2, that would be looking at this row here, and it matches the top row here, but they all changed signs. So I would need to multiply top row by -1 and ignore that bottom row in order for that rotation to work. All right, 180 degrees. We'll be thinking about the same thing. You can either take the original and rotate it 180, or you can take our 90-degree one and rotate it another 90 degrees, however you want to look at that. But it would become -1, -1, -2, 2, and -4, 2. So let's give you a visual here. So rotate another 90 degrees. Oh, I'm here. And so when we start looking at, well, what would I have to multiply by? That row matches this row, but we've just changed signs. So this would be a -1 here and a 0 here. This row matches this row, but again, all the signs are changed. And so with that, you'd have to go 0 and then -1. Okay, if you're watching this from home, I want you to try this last one on your own. Pause the video and then come back to see it. Rotating about the origin clockwise 270 degrees, or fun fact, this could be counterclockwise 90 degrees. So lots of different ways that you can find it visually. But when I do that rotation, I'm going to end up at -1, 1, 2, 2, and 2, 4. That's going to be up there. Okay, so again, let's find this matrix here. Notice that my top row is my bottom row, but different signs. So that means this has to be a 0 followed by a -1. And here, this is my top row exactly as it was here. So I need to keep it exactly the same. Again, with these, you guys can memorize them, or you can really think about how they're created. Just make sure that you do know the difference between each one of those. And that's it for transformations.